Bless you. Okay, I am recording y'all so I can post it. Just making sure I've got everything in the right spot. I do. Okay, so today we're going to be talking about factoring quadratic equations. Okay, so we briefly discussed this the other day, but we're going to get into the nitty gritty and make sure everybody understands and how to actually factor them. But before we do that, let's talk about some different forms of quadratic equations. So the very first one we need to make sure we remember is called standard form. So in standard form of a quadratic equation, this is probably a take notes type of thing. If you're a note-taking kind of girl or guy. Okay, y'all ready? Okay, so standard form is ax squared plus bx plus c, where a, b, and c would all be a number, right? If the number could be 1, or 0 if there wasn't something there. So like if you have an equation that said x squared plus 10, and there wasn't just a plain x in there, your b value in that instance would be 0, okay? It'd be 0x. We just don't write that. If it's 0x, we don't write that thing, right? If it's x squared and there's not a number in front of it, what is the understood coefficient of that? 1. So that would be a value that a was 1, right? Okay, now another form that we need to look at is called factored form. And factored form is when you have two binomials. I'm just making up random variables here, where the e and the f would be numbers, but the x's would be an x, possibly with a coefficient, possibly not, but it would be the x value in the front, okay? So far, so good? Boy, y'all got freakishly quiet. So far, so good. Okay, so now, why is this important? Well, if you look at the first questions here, it says, write a quadratic equation in standard form with the given roots, okay? Now, what that means is when they say that this is the given root, that means this is the value for x if y was 0. This is the x-intercept. That's what those roots are, right? So if we look at that as this means x equals 1 and x equals 4, like so, right? If I wanted to know what my binomials were that multiplied to get that, I just need to move this 1 and this 4 to the other side of the equation. How would I move that 1 to the other side of the equation? Subtract it. So what does it wind up being? So x minus 1 equals 0, or what's going on the other side going to say? X minus 4 equals 0. So this and this are our two factors. Those are the two things that would multiply to get our trinomial. So if we look at that as x minus 1 and x minus 4 are multiplied times each other, and we go ahead and multiply them out, that's going to give us standard form. So let's refresh our memory on how to multiply those. You may have, based on who you had for Algebra 1, you may have learned something called FOIL. Do you remember something called FOIL? Yeah. So all FOIL is an acronym to help you remember how to multiply these binomials. And F stands for first. That means the first two what? The first two terms. The first term in this one and the first term in that one. O stands for outer. That means the outside two terms. I stands for inner. That means the inside two terms. And then L stands for last, and that means the last two. Now, I don't normally teach FOIL. I'm just refreshing your memory if that's the way you learned it. But when I teach it, I just say we have to multiply this x times all this stuff. So that means x times x. Does that look familiar to first to you? And then x times negative 4, right? So what is x times x? X times negative 4. And then we have to multiply this negative 1 times all of this stuff. So see how it's exactly the same steps and exactly the same process? It's just a different way of remembering what to do. All you're doing is multiplying everything over here times everything over there. So what is x times, or negative 1 times x? Negative 1x. And negative 1 times negative 4? Positive 4. So then when we get to this point, we just say, okay, do I have like terms? And guess what? I have like terms. So negative 4 and negative 1x, I can combine them to get negative 5x. And so this, once you get down to this, that's your standard form. Now, what would a be in this form? What is our a value? 1. What's our b value? Negative 5. And what is our c value? Y'all see how simple that is? Okay. So we're going to do a few more of those. We'll do one more together, and then I'll let y'all do a few more on your own so we can make sure everybody understands it, okay? So let's do one together. Let's do number 2. So on number 2, they give you the values for 6 and 9, right? So that means that x must equal 6 and x must equal 9. So if I move these over to the other side so that I have a binomial, when I subtract this one, what do I get here? X minus 6 equals 0, right? I'm not going to bother with the equal 0 because we know we're just trying to get that binomial, okay? If I move this 9 over, how am I going to move it? What do I do to move that 9? I could subtract negative 9. That's an option. But what is the same thing as subtracting a negative value? Adding. So I could just add 9. And notice how if one's a negative and one's a positive, they cancel each other out. And now they're gone. So that gives us x plus 9 as this value. Are y'all with me? Okay, so now we have it in factored form. Now we just need to multiply it out to standard form. Girls, put your phones on my desk. Now, go take your phones and put them on my desk. Okay, so let's multiply them out. X times x, what is that? And then we multiply that x times that 9. 9x. And then negative 6 times x. What is that? Negative 6x. And then negative 6 times 9. Do y'all know how to do your 9s? Okay. There's a couple of different 9 hacks. Okay? So one of them, hold your hands up. Hold your fingers up. Whatever number you're multiplying 9 by, so you start like, let me turn my back to you. So you start like this, right? And whatever number, you put that finger down. So let's say I'm doing 9 times 4. So 1, 2, 3, 4. I put that finger down. This is my tens place. How many tens do I have? 3. These, everything on the other side of the finger is my 1. How many do I have? 6. Count that one too, right? So my answer of 9 times 4 is 36. Okay? So that works for all of them. So 9 times 6. So we put down this finger right here, right? How many fingers over here? How many fingers over here? 4. That's 54, right? Okay, let me show you another trick. I do that one, like for reals. But let me give you another nines trick. And you can do this mentally. You don't have to write this down, okay? If you're multiplying 9 times a number, if you're multiplying 9 times a number, subtract 1 from that number, and that's your tens column. So what's 1 minus 1? And then however many is left over from 9, from this number, you put in your ones column. So 9 minus 0 is 9. 9 times 1 is 9. Now, I know that y'all know what 9 times 1 is, but it works with every one of them. So if we subtract 1 from this, what's 2 minus 1? 1. And then do 9 minus 1. And that's your number. 9 times 2 is 18.
Wait, so you just subtract 1 from every single number?
So, right. So if we do 3 minus 1, that's 2. But then these two things have to, hey, y'all, I'm teaching. Y'all are being rude. Then these have to add up to 9. So we do 9 minus 2 and we get 7. So 9 minus 4, what is that? 9. I said 9 minus 4 and it's not what I meant. What is 4 minus 1? 3. I said 9 minus 4, you said 5 and I was like, what came out of my mouth and what came out of my brain were not the same thing. And then 9 minus 3 gives us 6. See how these always add up to 9? And it's 1 digit less. Your tens is 1 digit less than what you're multiplying by. So 5 minus 1, 4. And then this would be 5 because 4 plus 5 is 9. 6 minus 1 is 5. And then this would be 4 because 5 plus 4 is 9. Do y'all see how that works? I do the finger thing though. But this also works too. Okay, and you can do this mentally without being learned. Right? Okay. So back to our regularly scheduled program. What is 6 times 9? 54. But is it going to be a positive or a negative? Negative 54. Now, do we have anything to combine here? What do we got? 9x and 6x. So what does that get us? And this is our standard form. Okay? I want you guys to try number 3 and number 4. Try number 3 and number 4 and let's see how y'all do. So try this one and try that one. I just realized I never did roll.
This class has 22. Yeah, and my big class has 25. So we took 3 of each test. We have 3 of each test or 2? Oh, there is just 3. There's not 4. Oh, sorry. Oh. Isn't there a girl that sits with y'all? No. Never mind. Never mind. Do we have a new girl? Yeah, does she have? That's right. Okay. That's confusing me so bad. Trying to get her straight. All right, y'all have answers? Okay.
What do you think number 3 is? What is your answer for number 3? X squared plus 10? Is that what y'all got? That is the correct answer. So if that is what you got, yay you! Okay. What about number 4? Did you get that? I froze it. Shoot. Thank you, Hannah. Did you get x squared minus 7x? X, yes, it is minus. And I will tell you that I also messed up, and when I did it, I did not put minus either. But that's a positive 7, right? So x equals 7, so the binomial is x minus 7, because you have to move that 7 from one side to the other, right? Now let's talk about why there's nothing over here. So if we look at that problem, I'm going to just work it out here to the side. We have x either plus or minus 0. It doesn't make any difference, right? Because 0 has no value. And then we have x minus 7 because x equals 7. So if we move it over, that means it's a minus, right? So we're going to have x times x, x squared. X times negative 7, negative 7x. But then on this other end, it doesn't matter what is inside here. If we're multiplying it times 0, what do we get? 0. And there, it's not necessary to write 0, right? But just to show you, it would be 0x, right? And then it would be 0. But we don't write those. We don't write that part. We just write this part right here because adding 0 to something doesn't change it. Okay. Y'all get that? Does it make sense? You feel good about it? All right. So let's now work backwards. Okay. So if you look at number 7, you'll notice that on number 7, it says to factor, and it actually gives you the trinomial. So we're going to work backwards from this. Okay? So we're looking for which things multiply to get this stuff. Well, this right here comes from multiplying the first term times the first term. M and M. Slim Shady. Yeah, so we're going to get to that in just a minute. So the second part of this is we're going to actually look at the last part first. What? So this, remember on Friday when I wanted y'all to come up with all the factors of those numbers? This is why right here. What are things that multiply to get 18? 9 and 2. Is that it though? 1 and 18. That's 16. 3 and 6. Now, you do not have to list all the factors. You don't have to do that. Deonte knew as soon as she said 9 and 2 that was going to be the answer. How'd she know that? Where did she come up with this 9 and 2 at? And how did she know for certain that was what it was going to be? Well, she looked at what was going on in the middle. And what's going on in the middle comes from these being combined with each other in some way. Okay? Either added or subtracted. In this case, we would have to subtract 9 and 2 to get that. Right? So that means that we're going to have a positive 9 and a negative 2. How can we get a positive 9 and a negative 2 in here? What would we do to get a positive 9 and a negative 2? We would put plus 9 and minus 2. Okay, this method that I just showed you is how I was taught to factor, where you just think it out. You just use a thought process. Sometimes you have to plug in things and experiment and see what works, okay? And this is the way that it was taught to me. And I just see these. Like they just show up to me. But they don't just show up to everybody. And if they just show up to you, you are more than welcome to do it just like this. All right? Are you okay? Yeah.
I'm sick, and I took medicine. I'm like tired.
Okay, I'm just checking on you. Just making sure you're all right. Okay, so if you see them like I do, if you're good at multiplication facts and good at mental math, you'll probably just see these. But if you don't just see them, I have a solution for you. Okay? Took me a long time to develop this, but I finally developed a way, and we're going to do the exact same problem again. We're just going to do it a little bit differently. All right? So, I'm showing you this on an easy one, on one that's real easy to get. But then you'll see how it's super helpful when they're more complicated. All right? Even for those of you who just see them, the more complex ones are harder to just see. So the first thing that we're going to do is we're going to start off by making us an X. And at the top, we're going to put A times C, whatever the value of A times C is. So in this case, in this problem right here, what is our A value? 1. And what is our C value? So what is A times C in this problem? Negative 18. And down here, we're going to put whatever our B value is. So what is our B value? 7. Okay. Now what we need to do is figure out what numbers could go here and here that would multiply to get negative 18. Right? So they multiply to get this, but they add to get that. Okay? Now, we already did this one, so we know what those answers are. What are the two numbers that would multiply to get negative 18, but add to get 7?
9 and negative
9 and negative 2. Now, since this is a basic one, we could actually stop right here. But I want to show you the next step for the ones that are harder. Okay? So if they are harder, then we're going to go from this into a Punnett square. Do y'all remember Punnett squares? Yeah, from science.
Oh, I remember.
Do you remember where you learned like blue, big B, little b's? Y'all remember that? I've always been fascinated by that.
Did you teach us last year?
I did. I sure did.
And I didn't like it because I got confused.
Okay. Interesting fact. Fascinating piece of information for you. I am the oldest of 6 children. Of my siblings, all of us have some form of brown eyes. I have one brother whose eyes are hazel, but hazel is just brown-green. That's all that is, right? Between me and my siblings, there are 5, 6, 7, 8, 9, 10, 11 grandchildren. Between me and my siblings, we have 11 kids. Every single one of those kids, except one, has blue eyes.
Is that you?
No. Grandkids.
Oh, okay.
All the grandkids. No, my sister's girl, that actually looks like me, has brown eyes. But all the rest of them have blue eyes. Every single one of them.
My cousin had all his kids have green.
They all have green eyes. Okay, so that was just a side note that goes along with y'all remembering this, okay? Now, how do we use the information we just got right here in this? Well, what we're going to start with is whatever our first term is going to go in this square. So our first term is going to be right here, m squared. Okay? Whatever our last term is going to go in this square right here. That's the m squared and the negative 18. And then these two will be these two. So one of them is going to be 9, and one of them is going to be negative 2. So 9 is going to go in one, negative 2 is going to go in the other. Now what we're going to do is figure out what would be here and here so that when they multiply, they get m squared. So what would go right here and right here to multiply to get m squared? M and m. And then we figure out, okay, what could multiply right here to get 18, but also gets us 9. I forgot my m's there, y'all. 9m right here. So what would we multiply m by to get 9? 9. And what would we multiply m by to get negative 2? And does 9 times negative 2 give us negative 18? So our factors here are, we already figured this out, but m plus 9 and m minus 2. M plus 9 and m minus 2. Are you okay? Okay, just checking. Okay, everybody good so far? Now, like I said, this is not necessary unless factoring is hard for you. If factoring is hard for you, this makes it a lot easier. Okay? So you can do it however it floats your boat. Whatever works for you. I will continue to do it like this in class because so many students struggle with this, okay? And this just breaks it down step by step. But you personally do not have to do it this way. This is just helpful for those who really struggle with this. All right? Okay, so like if we look at number 8. What time is it, y'all? What time?
11:30.
Perfect. Thank you. Okay, so this is our thing, right? So we're going to start with our big X. And up here we're going to put A times C. So in this case, what is our A value? What is our C value? So this is negative 10. Down here, we're going to put our B. What is our B? Almost. Negative 3. So we're looking for things that multiply to get this, but add to get this. What are numbers that multiply to get negative 10, but add to get negative 3?
10 and 7. 10 and 7.
Multiply to get 10.
2 and 5. 1 and 10.
Okay, we're 2 and 5, 1 and 10. Which of those is going to work?
2 and 5.
Okay, so how is it going to work?
Oh, I thought that was a 7. If the 5 is negative.
Oh, that's a negative 1. That's a negative. My bad, Ellie.
I thought it said 7.
I was... Yes, ma'am. Okay, I was so confused. All right, I was like, where'd she get that 10 from?
Unless it could have been negative 3, it could have been the answer too.
Yes, it would have worked.
Yeah,
It absolutely would have worked. Yeah. Now that makes so much more sense than you randomly saying 10 and 7.
Yeah, no, I saw you looking at me like.
Yeah. I was concerned about your mental state. Okay. How do we get a negative 3 out of that, though?
5.
The 5 has to be negative, right? So now we know those signs that go in there. So now let's go plop this sucker in our Punnett square. So when we put it in our Punnett square, 2x squared goes up here. Negative 5 goes down here. That's our first and that's our last, right? Now, when you have a coefficient right here, sometimes you have to do a little manipulating to figure out where what goes here. Okay? Sometimes you have to move things around a little bit. But if we put 2x in this one, and we put negative 5x in this one, let's see if we can make this work. All right? So what would we multiply to get 2x squared? 2x and x. Since there's a 2 down here also, we need to put the 2x right here and put the x right there. Does that make sense? Okay. Now, what would we multiply negative 5? Oops. What would we multiply x by to get negative 5x? So we put negative 5 right there. What do we multiply 2x by to get 2x? 1. So a 1 goes right there. Y'all following me? Does negative 5 times 1 equal negative 5? Yes. So here's our factors. Right? We have 2x minus 5. I always write the one with the bigger coefficient first. And then x plus 1 because it's a positive 1. Now if we want to check this to see if we got it right, all we have to do, this would be our answer right here. But if we want to check it, we would multiply it out and then see if we get what they asked us to factor. Okay? So if we do 2x times x, 2x squared. 2x times 1, positive 2x. Negative 5 times x, negative 5x. Negative 5 times 1, negative 5. Do these combine in the middle to get the right thing? There we go. Everybody clear? This is not that bad, right? Not that bad. You remember going over it last year? I know Mr. Lester went over it, and I know I went over it. I hit it pretty hard, actually. Because I felt like I was going to wind up teaching Algebra 2 this year. Didn't know for sure yet, but I felt like it.
I feel like it was confusing. It was more confusing than last year.
Your brain is more developed, and so it's easier for you to learn things. And also, this is the third time you're seeing this. Because you saw it in Algebra 1, you saw it last year, you saw it this year. Is it almost bell time? What? 08, so we have 7 minutes. Yeah, let's go ahead and just shut down there, and then tomorrow you guys will work, and I'll help you if you need help, okay? Okay. What are you doing Friday?